Hello students, we are solving the IB Math EHL past papers and currently we are solving the IB Math EHL May 2021 paper 2 time zone 2 past paper. And today we will be solving the question number 11, that is the second last question of this paper. And you will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in the description area. So without any further delay, let us start answering question number 11. The maximum mark is 18. And the question says a function f is defined by f of x equal to k times e to the power of x over 2 over 1 plus e to the power of x, where x belongs to the set of real numbers, x is greater than or equal to 0, and k belongs to the set of positive real numbers, means k will be a positive number. The region enclosed by the graph of y equals f of x, the x-axis, the y-axis, and the line x equal to ln of 16. Maybe I'm not sure what will be the shape of this graph. Anything, it may be this way, it may be that way. No idea. But whatever it is, this is the x-axis, this is the y-axis, and this is the ln of x equal to ln of 16. Maybe this is the line, ln of 16. Okay, so this is x equal to 0. And this is the x-axis. So the region enclosed, this one is this, is rotated 360 degree about the x-axis, about this x-axis, to form a solid of revolution. And subpart A, show that the volume of the solid formed is 15 times k squared pi over 34 cubic units. So we know the formula for the volume of the solid formed is given by the integral of pi f of x whole square, it may be written as y square as well, dx, and what will be the two limits? X equal to 0 to ln of 16. X equal to ln of 16. Okay. So now we will be just substituting the expression of f of x. Ln of 16. I can take out the pi because it is just a constant. I am taking out the pi, and k, it will be k squared because f of x whole square, so this is squared and this is also getting squared. Okay, so it is k squared, and e to the power of x over 2 whole squared is e to the power of x. So it is e to the power of x over 1 plus e to the power of x whole squared. I'm keeping it as it is. I'm not expanding this part. Dx, okay? And I can take out the k square as well. It is also another constant, so I'm taking out that. This is from 0 to ln of 16. E to the power of x over 1 plus e to the power of x whole squared dx. Okay, now we have to perform the integration. How do we do? We will be using the substitution method and we will be substituting the denominator expression. So that e is equal to 1 plus e to the power of x. So dt dx is equal to e to the power of x Okay, or dt is equal to e to the power of x dx. We are having e to the power of x dx in the numerator, so that will get replaced by dt. And in the denominator, you will be having t square, right? So the expression, we understand that, okay, let me just write the expression. So this is k squared pi. I have the k squared pi in front, okay? And ex, e to the power of x dx is dt over t square. But what about the x equal to 0 and x equals ln of 16? Because we have changed the x to t. So we have to change the limits as well. Either you change the limits, that is one of the methods, you change the limits and you perform the definite integration, or else you perform the integration in this way, the indefinite integration, normal integration, and you get the expression in form of t plus c, and then you put back the expression for t, that will be 1 plus e to the power of x. So you will be getting an answer, an expression containing 1 plus e to the power of x. You will be getting back the x part in the expression. After you get back the x part, you can take the limits as x equal to 0 and ln of 16, x equal to ln of 16. That will be correct. But in case you want to change the limits and go for the definite integration, I am showing you how to change the limits. But again, I am saying that do not try to change the limits and get some wrong answer, get some wrong limits. Okay. So when x equal to 0, t is equal to 1 plus e to the power of 0. E to the power of 0 is 1, so 1 plus 1 is 2. And when x equal to ln of 16, t equal to 1 plus e to the power of ln of 16, and e to the power of ln of 16 is 16. So t is equal to 1 plus 16, that is 17. Okay. So the limits will be from 2 to 17. This is, let me write the k squared pi. It is not having any space over here, almost on the verge of starving. Okay. So this is, sorry, from 17, e to the power of negative 2 dt. And if we have to integrate it to the power of negative 2, what will we be getting? It will be negative 2 plus 1 over negative 2 plus 1. So it will be to the power of negative 1 over negative 1. So this is k squared pi e to the power of negative 1 over negative 1, 2 to 17. I can take the negative sign outside, so this will be negative k squared pi. And t to the power of negative 1 can be written as 1 over t. To the power of, means the limits will be 2 and 17. So it is negative k squared pi, and it is 1 over 17 minus 1 over 2 equal to negative k squared pi. The common denominator should be 34, and it will be 2 minus 17. So this is negative k squared pi times negative 15 over 34. And negative times negative will be giving us a positive number. So it will be 15 k squared pi over 34 cubic units. Okay. So this is this we have shown. This is our answer for subpart A, and we move on to subpart B of this question. Pedro wants to make a small bowl with a volume of 300 centimeter cube based on the result from part A. The result of part A is this one, 15k square pi over 34 cubic units. Pedro's design is shown in the following diagrams. This is the graph for y equals f of x, and this is x equal to 0, and this is x equal to ln of 16. And this has got rotated around the x-axis 360 degree. After 360 degree rotation, this bowl has got formed, and the vertical height of the bowl BO is measured along the x-axis. This is the BO, the height ln 16. And the radius of the bowl's top is OA, this one, and the radius of the bowl's base is BC, this one. All lengths are measured in centimeters. And subpart B says, find the value of K that satisfies the requirements of Pedro's design. Pedro wants to make the bowl have a volume of 300 centimeter cube, and this is the expression for the volume. So we will be just equating them. So this is subpart B, and it is 15k squared pi over 34 is equal to 300. Therefore, k squared will be 300 times 34 over 15 pi. We have to find the value of k, so we have to take the positive square root because k is a positive number. We have been given k to be a positive real number, so it will be the positive square root 300 times 34 over 15 pi. Now this is a paper 2 question, so we'll be using the calculator. So square root, the numerator is 300 times 34. The denominator is 15 times pi. Okay. 14.7123. 14.7123. So up to three significant figures, it will be 14.7 centimeter. Up to three significant figures. Okay. This is the value of K. Okay. So now coming to subpart C. Find, it has two further subparts. I is OA and II is BC. So I is OA. We have to find the length OA. And you see this is OA is on the y-axis. So for both the O and the A points, x value will be this equal to 0. And for O point, the y value is 0. We have to basically find the y value for the A point. And This is the expression for the y or f of x. So we will be just taking this, we will be putting x equal to 0 and we will be finding the y value for the point A. So this is part C, I, y equals, A is 14.7123, I am writing, times e to the power of 0 over 2 over 1 plus e to the power of 0. Okay, and e to the power of 0 is 1, and e to the power of 0 over 2 is e to the power of 0, which is equal to 1. So this is 14.7123 divided by 1 plus 1 is 2. So this is equal to taking the answer divided by 2. 7.356. Okay, let me at least write 7.356. 7.356. So up to 3 significant figures, it will be 7.36. Okay. Therefore, OA is equal to 7.36 centimeters up to 3 significant figures. And II is BC, this one, when x equal to ln of 16. So we will be putting ln of 16 in place of x. So it is again 14.7123 times e to the power of half times, I am writing half times ln of 16 because it is x over 2 over 1 plus e to the power of ln of 16. Okay. And this half can be taken to the power. It will be 16 to the power of half, which is 4. Okay. So this is basically 14.7123 times e to the power of ln of 4. Okay, because 16 to the power of half or square root of 16 is 4. So it will be e to the power of ln of 4, which is 4. So this is 4 and this one is e to the power of ln of 16 is 16 and 16 plus 1 is 17. Okay, so this will be equal to 14.71. Okay, let me again take 14.7123 times 4 multiplied by 4 over 17. 3.46. I'm taking 3.46. I don't have to take any other digit because I have to, in fact, give the answer in up to 3 significant figures. So I'm writing 3.46. So BC is writing this over here because I don't think, let me try. Therefore, BC is equal to 3.46 centimeter up to 3 significant figures. Okay. BC is 3.46. I'm not sure whether you are being able to see that part. So I'm just writing it over here as well. BC is 3.46 up to 3 significant figures. And this one is 7.36 centimeter up to 3 significant figures. Okay. So we have completed answering subparts B and subpart C. We move on to subpart D. For design purposes, Pedro investigates how the cross-sectional radius of the bowl changes. Subpart D, it contains further two subparts I and I. I is by sketching the graph of a suitable derivative of f. Interesting. They have not asked you to sketch the first derivative or second derivative, a suitable derivative of f. Find where the cross-sectional radius of the bowl is decreasing most rapidly. You see, this is the cross-sectional radius of the top, and this is the cross-sectional radius of the bottom. So the radius is constantly decreasing, definitely. It is not increasing at any time, it is decreasing. But they are saying, where is it decreasing most rapidly? Since it is changing, therefore rate of change of f of x, the cross-sectional radius, will be f dash x. Up to this point, it is fine. Students come to this f dash x part. They know that they have to take f dash x, at least f dash x, and they have said the question itself suggests that you have to take one derivative. So either you have to take f dash x or f double dash x. What should it be? Since the radius is decreasing, okay, rate of change of the radius, so it is f dash x, fine. So but let us just write that. Since the cross-sectional radius is decreasing, okay, let me write within bracket changing, therefore the rate of change of it is given by f dash x. Okay. Now comes this clause decreasing most rapidly. And I have seen students getting confused at this point. They have come to f dash x. Now they just consider thinking that how to find where is it decreasing most rapidly. If we graph f dash x, should we be taking the maximum point or should we be taking the minimum point, or which point should we be taking? So In fact, if you graph f dash x, you will be seeing you will be getting only a single minimum point. You won't be getting any maximum point. But before graphing it, of course, you don't know. Means maybe you don't know because the question or the graph over here suggests that you will be having only a minimum point if dash the f of x is decreasing. So it is the rate of decrease. I have written first decreasing, and then just to make it more clear that it is changing, that is rate of change is f dash x. So I have written the word changing as well. In case you are confused as to whether to take the maximum or minimum, what is it, Miss? You will be having only a single minimum point, and you may graph f dash x and get the minimum point, or else the maximum rate of change is for that point if double dash will be 0, because the most rapidly means the maximum rate of change, most rapid rate of change. Okay, for that, definitely the second derivative should be equal to 0. So you may try sketching the second derivative as well, because you know most rapidly means it is the maximum rate of change. Okay, so for that, f double dash x should be equal to 0. Okay? So let us write for the point where it is decreasing most rapidly, if double dash x is equal to 0. Okay, so let us graph the if double dash x. You may get the second derivative expression. You can differentiate twice. The question contains 6 marks. This one may, most probably this one will be 2 and 4, because this is just state the cross-sectional radius of the bowl at this point. So we have to get the point, the x value, and we will have to substitute x in this expression. So this will not be containing more than 2 marks, and this will be containing 4 marks. So if you want and if you have time, you will be having the full question 12 remaining. Okay. So if you want, you may get the second derivative expression or the first derivative expression in if you want to sketch the first derivative graph, or else if you have to go, if you want to go for the second derivative, you may get the second derivative expression, absolutely fine, but you may avoid getting those expressions. Okay, and you may save some time. So how do you do that? Let us go to graphs. So before going to graphs, let me just take this expression. Okay. It is 14 times 14.7123 was the k value. So let me write that 14.7123 times e to the power of x over 2. Over 2, and denominator is 1 plus e to the power of x. Okay. Okay, and I'm storing this in f of x. I'm naming this expression as f of x. It is the f of x expression. So I have made the computer know that this expression is referring to f of x. And then we go to the, and done. I have to do, okay, fine. Computer now saves this as this expression as f of x. So now we go to the graph portion, add graphs. Okay, and now we need the second derivative of f of x. So we go to, this is the second derivative. Okay, and this one, we go to this var variable, the only one that I have saved. So it is this. So I'm just asking the calculator to get the graph of the second derivative. I am not giving the calculator the expression for the second derivative of f of x. Rather, I have given the expression for f of x, which is given in the question. And I'm asking the calculator to do the calculation and give us the graph. Okay. So this is, okay. And it should be from x equal to 0. So let me just take from x equal to 0. Window settings, from x equal to minimum is 0. And the remaining everything is fine. Okay. And as I have said that when the radius is decreasing most rapidly, if double dash will be equal to 0. So we have to find the x value for this point. So menu, analyze graph, and we need the 0. It is 1.7627. So let us just write this 1.7627. Okay. So, and okay, not only do we write this because we have to sketch the graph. So we need this. This is, what is this? Okay, let me just go to trace, graph trace. This is what, this is x equal to 0 value. 0 and negative 1.839. And this is 1.7627. And what is the maximum? Okay, let me just first of all write 0 and negative 1.839. So negative 1.8 MT. Okay. So there will be a point as 0 and negative 1.84. And there will be 1.76 comma 0 and escape. Okay, 1.76 comma 0, and then let me go to the maximum point. What is the maximum? Analyze graph max. Where over here? It is 3.09, 3.09 and 0.5. 3.09 and 0.5 maximum. Fine. So this is in fact the shape that we have to sketch. Okay. Let us try. It is will be negative. It is 0.0. I can take negative 1.5. I don't. I can take up to. And need another one. This will be, this is this. I can take this up to. So now I just plot the points. This is 0. This is negative 1. This is negative 2. Okay. And this 1. This is 1. Okay. And this is 1. 3. Okay. And in fact, I don't need the up to ln of 16 or thing. By sketching the graph where we have to just show the 0. So 0 will be 1.76 maybe over here, and it will be maximum for 3.09 and half over here. And the y-intercept 0 and negative 1.4 over here. Okay. So it will be like this somewhat. Somewhat of this shape. See, it is somewhat of this shape. And 1.7627. This one is 1.7627 x value. Okay. So this will be the find where the cross-sectional radius of the pole is decreasing most rapidly. So it is decreasing most rapidly. This one is f double dash x. Then x is equal to 1.76. Up to these significant figures. Yeah. And now we come to subpart II. Okay. And it says state the cross-sectional radius of the bowl at this point. So it will be f of 1.7627, which is, we have in fact stored f of x expression. So we will be just computing f of 1.7627. We go to the calculator and we take F1 is the graph drawn, so don't take F1, take F. 1.7627. 1.767. 5.20. Okay, 5.20. So 5.20 centimeters. This is the cross-sectional radius. This is up to 3 significant figures, of course. Radius when x equal to 1.7627. Sorry, this is 2, this is 7. So cross-sectional radius when x equal to 1.7627 is 5.20 centimeters up to 3 significant figures. And with this, we complete answering question number 11. And I'm Nilanjana Sanyal. I tutor IB Math A, SL and HL students online from within India and outside India. And I'm starting small group online tuition for the IB Math ESL and IB Math HL students. So if you are interested in joining those groups, you may contact me for more details. You are seeing my email ID getting displayed. You are seeing my WhatsApp number getting displayed. So you can contact me for more details. Okay. And thank you for staying with me till the end. We meet again very soon with our question number 12. That is the last question of this paper. So till then, bye.